Okay, so what we're going to be solving today is a system of equations. It's going to be 3 equations and 3 unknowns. So it'll be, the 3 unknowns will be such as x, y, and z. All right, so we're going to just review, I'm going to take a look at this, and review solving a system of linear equations using the elimination method. All right, so you guys did this back in algebra. All right, so the elimination method, just really quickly, the elimination method is when you want to cancel one of your variables out. Okay, so you want to cancel a variable out. Oops. Okay, and to do this, you want to get opposites. So you need opposites. Okay, so let's take a look at what we have here. I have 2x plus 5y equals 20, and 3x plus 2y equals 19. Okay, so what you want to do is decide, are you going to work on canceling out the x's or work on canceling out the y's? It does not matter which one you decide to do. You'll get the same answer either way. So for me, what I'm going to do is I'm going to work on canceling out the x's. So to cancel out the x's, you want to get opposites here. So you're going to have to do multiplication here. So I need to multiply the first one by something. I need to multiply the second one by something. So I want these x's to cancel out. So you want to find, it does not necessarily have to be the smallest number. It's easier if you get the smallest number that 2 and 3 both go into. Or you could just multiply each equation by the other coefficient. So I'm going to multiply this one by 3, and I'm going to multiply this one by 2. Now this will give me, when I distribute, this will give me a 6x, and this will give me a 6x, but they're not opposite, so I need one of them to be a negative. So I'm going to make my bottom one a negative. So I'm going to distribute the 3, so I'm going to get 6x plus 15y equals 60. And now I'm going to distribute the negative 2. So I'm going to get negative 6x minus 4y equals negative 38. All right, now we're going to add them. So when we add them, those will cancel out. So this here, 15y minus 4y becomes 11y. And then 60 minus 38 is 22. Divide both sides by 11. My y is equal to 2. All right, now that you have your y value, you want to find your x value. So over here on the side, put find x when y equals 2. So you want to go back to one of your equations over here. It does not matter which one you pick. I'm going to pick the top one to plug my y value in. So I'm going to use 2x plus 5y equals 20. And I'm going to take my 2 and plug it in for the y value. So that's 2 plus 5 times 2 equals 20. 2x plus 10 equals 20 minus 10. 2x equals, 2x is equal to 10. Divide both sides by 2. And x is equal to 5. And so I have a solution. And my solution is x is 5 and my y value is 2. All right, so we're going to use the same type of process to solve a system of equations that has 3 equations with 3 unknowns. All right, so let me just switch here. Okay, so now here I have my 3 equations and my 3 unknowns, my x, y, and my z value. All right, so the first thing I want you to do is just to label on the side equation 1, equation 2, and equation 3. Just so when I refer to the equations, I don't have to say the whole equation. If I say equation 1, no, I'm talking about the first one, the second one, and the third one. All right, so the first thing you want to do is take equation 1 and 2, so rewrite 1 down here. So x plus y plus z is equal to 1. And equation 2, which is 2x plus 4y plus 6z is equal to 2. All right, now what you want to do is you want to use the elimination method to get rid of one of the variables. It does not matter which variable you get rid of. I'm going to choose to get rid of the x's. That's all. So notice I have a 2x down here. I want to make this x up here a negative 2x. So I'm going to multiply this by a negative 2. Just make sure you distribute all the way through by that negative 2 all the way to the end. So it's negative 2x minus 2y minus 2z is equal to negative 2. We'll keep the bottom one the same. 2x plus 4y plus 6z equals 2. Now we're going to add them. So my x's will cancel. I have negative 2y plus 4y is 2y. I have negative 2z plus 6z is 4z. And this is nice, this becomes 0 down here at the end. All right, so now I'm going to call this equation A. So just put an A next to it. Now I'm going to go back to my original equations. And now I'm going to use equations 1 and 3. So rewrite 1. So 1 is x plus y plus z is equal to 1. And equation 3, which is x minus 3y plus 5z equals negative 11. Now what you want to do is eliminate one of the variables, but it has to be the same variable that you eliminated over here, which are the x's. So I have to eliminate my x's here. So they're both 1x here. So I just have to multiply one of them. I'm going to multiply the top one, it doesn't matter which one, by negative 1. Just make sure you distribute all the way through. So it's negative 1x minus 1y minus 1z equals negative 1. The bottom one will stay the same. 1x minus 3y plus 5z equals negative 11. Okay, and together, my x's cancel. So I have negative 4y plus 4z equals negative 12. And you're going to call this equation B. Okay, so now what you want to do is you want to take equation A and equation B, and now you're going to solve them. You're going to solve for x and, y and z, just like we did in the do now. All right, so let me just rewrite these. So I have equation A. All right, so you can label it A if you want. 2y plus 4z equals 0. And equation B is negative 4y plus 4z equals negative 12. Okay, so now you want to eliminate one of your variables, the y or the z's. It does not matter which one you eliminate. However, though, if you look at the z's, they're both 4z. You just need to make one of them a negative. So that's probably the easiest one to do. So I'm going to multiply the top one by negative 1. So just rewrite that. So that's negative 2y minus 4z equals 0, right? Because negative 1 times 0 is 0. We'll keep the bottom one the same. That's negative 4y plus 4z equals negative 12. All right, so my z's, they cancel. So I have negative 2y and negative 4y is negative 6y. Equals 0 minus 12 is negative 12. Divide both sides by negative 6. And I get y is equal to positive 2. So I have my y value here. All right, now I want to use one of the equations, the new equations that I have here, either A or B, to find my z value. Right, because I have my y value here. Now I have to find a z value. I can't go back to these guys yet. I have to keep with this. All right, so now I'm going to find a z value. So over here on the side, I'm going to write find z when y equals 2. It does not matter which one you use. I'm going to use the first one. 2y plus 4z equals 0. So I'm going to plug in 2 for my y value. 2 times 2 plus 4z equals 0. 4 plus 4z equals 0. Minus 4 from both sides. 4z equals negative 4. Divide by 4. Z is equal to negative 1. So now I have my z value here. All right, so I have my y value. I have a z value. Now I need to find my x value. Now is the time you're going to go back to one of your equations, either 1, 2, or 3, and you're going to plug in z and y to find your x value. Now, obviously, it looks like the first one is easiest to plug in, so that's the one I'm going to use. All right, so right down here, I'm going to find x when y equals 2 and z is equal to negative 1. So I have x plus y plus z is equal to 1. So plug in nothing for x, that's what we're looking for. Y is 2. Z is negative 1 equals 1. X plus 2 minus 1 is 1 equals 1 minus 1. X is equal to 0. So that's my solution. My x is equal to 1, my y is equal to 2, and my z is equal to negative 1. All right, so that's it, and have a good night. See you guys tomorrow.